So, yes, we need to consider a typical exam question working with the nature of our roots. As we had our previous class working with the nature of roots for those who managed to be part of the introduction. So this is it, guys. We are given on question number 3 to determine the nature of the roots of the following graphs. So they were given in terms of the graphs. All right. They gave you in terms of what? In terms of the graphs. Like I said on the introduction, that you can be given this in form of the presentation of a graph, like this part here, if you still remember, when I was representing this graphical presentation here. So this is what we have. The first part we can see from our x-axis. The graph does not pass through the x-axis. Okay, look at our graph, and this is our x-axis. The graph does not pass through the x-axis. When you are talking of a quadratic function, this is a quadratic function. We know that for it to have the roots or the solutions, like I stated, guys, it must pass through the x-axis like this. We must have this function passing through the x-axis. Yes, it can even pass through the x-axis at one point. It can have that condition where it is passing through one point, where it just crosses and actually bounces at this point. It bounces back. But this one, it does not even cross the x-axis. So what is it about the nature of the roots? Meaning to say the x values, they do not exist in our case. They do not exist. They do not exist. We do not have the x values in our case. They do not exist. The roots are non-real. That is imaginary. We cannot see that. Okay, let's go back here. If you still remember when when I represented here, this one. This is exactly the content that you have there here. The graph does not pass through the x-axis. The roots are non-real or imaginary roots. So there we are talking about what? The roots, all right? Sorry for that. Why is it so big like this? So you can say our roots, that is, the roots are non-real. They do not exist mathematically or imaginary. So you can also refer that as what? Imaginary. Meaning to say, if they are imaginary in our case, what is it about the delta? It's a negative value. Our delta in that case, it's a value which is what? Less than 0. Negative. That is the condition of our delta in that case. It's a value which is what? Less than 0. A negative. Okay? So that was the condition, guys. Let us see then 3.12. We are given. So as you can see, there's a quadratic function, and this one, it bounces in the x-axis, it bounces back at this point. At one point, only at one point. So we do not know, guys. Remember the solutions when it is like this, when it is at one point, we do not know to say like, okay, it can be like this. Actually, I wanted to refer like this one. It can be like this. Same condition, but it's at one point. So what is it about the discriminant in this case, about our delta, the number that was under the square, because this number is the same. And we actually understand that this number is going to be a rational. That is what we know. It's going to be a rational number. When the solution is all a single solution, guys, there is no way. Here, it can be a condition, all right? It's okay. It's actually something I wanted. Let me put it this way. On this one, it can be a condition where these roots can be rational, can be irrational. But when it is like this, when it is only one solution, guys, that one will be a rational number. Remember, this is the condition when we have what? When we have a 0 there. Here. When we have a 0 under the square root, when our delta is equal to 0. This is the condition that I was talking about here. So there we have got what? Rational. Rational. The rational part is supposed to be part of your answer. So in our case, these roots, what are they? So we can say the roots 1, they're equal. All right. We saw that they're going to be equal. So we could say they are real. Equal. Equal. There is no way, guys, here that we can have any other part here. Guys, it only when we have got one solution here, one solution here. When there is one, it means it was a 0 there. So definitely we know that they are rational here. So these roots are real, equal, and what? And rational. These were the conditions, remember, from our notes. Because of what? Our delta being equal to what? Equal to 0. When we have one solution, this is what you can present your answer as. All right. So quickly, looking into the other part, show that the roots of this equation are rational. Take note, they are rational, meaning to say the roots can be expressed as A over B. Remember, rational. For all value or values of K. For all value, or they can be values of K. So guys, once you're told this, let's go back to where the rational plays a role, because this time we are given, those were graphs. That's why I was giving you this graphical presentation, but they were given the quadratic equation. Remember, guys, the format of the quadratic equation, which gives us these solutions. So we want to pick exactly which is being stated here. Rational. When the roots are rational, what do we expect? Where do we have rational? This is what we're going to check here. So it is either for us to have rational roots. We want where the rational is. Rational. Here, we've got rational. When our delta is equal to 0, rational is there. So we are going to expect something of this nature. Our delta to be equal to 0. Again, where we have got rational, when our delta is greater than, which is a positive, when it is a positive and a perfect square, the rational is there. So those are the two conditions that we are going to expect for our delta. For us to have a rational number here, it means our delta is equal to 0, or we have a condition where our delta is equal to what? A perfect square. These are the only two conditions, guys. When it is what? A perfect square. Guys, read your notes. Rational part here or here. So if you can prove these two, any of these two, we do not know, because this is a question that you're given. So we're going to see from there. Is it going to be equal to 0, or is it going to be a perfect square? If it satisfies one of these, therefore, these roots are rational for all values of K. So like I said, guys, this is a quadratic equation. Why? Guys, look at this equation. This is kx squared. Look there. Just like 2x squared. They just want to confuse you. They just want to confuse you. You see? So once you understand that it is supposed to be in the form ax squared plus bx plus c is equal to 0, we see that this is kx squared. We move on here. Look, we've got x there. This is plus 2k minus 1 into what? X. This is x. Exactly the format of our quadratic here. Ax squared. All right? Plus what? Plus bx plus c, the constant. This is the part of what? X squared. This is the part of what? Of our x. What about the constant? So the constant is the part where we do not have x. Totally, we do not have x. And this is the part that we have here. So we have to take it to the other side so that we properly see our constant. So k to the other side, this minus k, once it crosses the equal sign, was going to be positive. Remember, one side must be equal to 0. The plus 1 to the other side was going to be what? A minus 1. That's equal to a 0. One side must be equal to 0. So, guys, this is our constant. As you can see, it's a plus here, guys. This one is a plus. So we can open a bracket. The plus does not affect, so that we properly see what is our constant. So the constant is this one, the k minus 1. We have exactly the format of a quadratic equation, but they are hiding it. Look, guys, ax squared plus bx plus c. So we said once we have this, to know about the roots, find what? Delta. So let's find our delta. Our delta is equal to what? B squared minus 4ac. So let us find it. But we are finding it in terms of k. Just like there was a number here, which is 2, there's a 3, there's a 7. How were you going to substitute? This was our previous class. When we were given something like x squared minus 5x plus 6 is equal to 0. This is exactly the same. This is your A, your B, your C. This is exactly what we have. So the coefficient of what? X squared, that is our A. The coefficient of X, that is what? Our B. And this is our constant, which is C. So let's substitute, guys. B squared, this is our B, and it's a positive. So we're going to take that bracket as it is. 2k minus 1. This is B squared. So that's a squared. Remember, it's a positive, so nothing is affected. Minus 4 times A. Our A is what? The coefficient of x squared, which is k. Into what? C. What is our C? The constant k minus 1. That's a positive there, so it's not affected. So you're going to take this as what? K minus 1, like this. That's your condition. Simplify this so that you properly see, is it going to be a perfect square or equal to 0? Let's see. So let us simplify our delta, guys. So expansion of bracket, that's where those special expansions of your binomials play a role, guys. Remember, I explained this. If it is not to you guys, it means I explained to the grade 10s. So it's fine. You can work that, or you can just expand your brackets properly, or you can use your identities. A minus b squared. Remember, this is a squared minus 2ab plus what? B squared. So in our case, a, the first term. Okay, let us just do this. So this is our a, which is 2k, and our b is what? 1. Not minus, but the 1, the number, which is just 1 as it is. All right. So using this, we're going to have a squared, which is what? 2k squared. That is our a squared. 2k squared. That's what? 2 squared. That is what? 4k squared. Everything is raised to the exponent of 2. So that was going to give us 4k squared. All right. Then we move on. Minus 2ab. That's minus 2 times our a. Our a is what? 2k. All right. Then our B is what? Our B is 1. Take note, guys. Do not take the negative. The negative is here. This is the negative sign that you are using. So it's already used in the formula. Don't take it. Just what is representing A and B. Okay. So multiply this. You're going to get what? Minus 4k. That's minus 4k minus 2 times 2 times 1. That's minus 4k. All right, then the last part is what? B squared plus B squared. So it's plus B squared. Our B is what? Our B is 1. So that's 1 squared, which is 1. So that was going to give us 1. So we have expanded this, guys, or you can just use 2 brackets, expand the 2 brackets as usual. You're going to get the answer. Then after that, we need to expand this part of what? K minus 1. Distribute by what? By the minus 4k outside. So this is minus 4k outside of the bracket. So minus 4k times k. This is minus 4k squared. Then we've got minus 4k times minus 1. Minus to a minus, that's a positive. So that's positive 4k. We can collect our like terms. As we can see, we've got 4k squared minus 4k squared, it was going to cancel. Minus 4k plus 4k minus 4 plus 4, that's a 0. So you're going to remain with what? A 1. Our delta, our discriminant is equal to 1. It is equal to 1. This is not equal to 0, all right? But it is what? 1. So we have to check now because it is not equal to 0. Guys, this is what we're expecting our answer to be equal to 0 or what? A perfect square. So it failed to be equal to 0. We remove this one. We test the last one. Those are the only two, guys, where we have got real, here and here. When it is 0 or when it is a what? A perfect square. So we test for the last one. Is it a perfect square? Is 1 a perfect square? Yes, 1 is a perfect square. So remember, square root of 1 is what? Plus or minus 1. We can simplify the square root of 1. So that's a perfect what? A perfect square. 1 is a perfect square. This is the condition. 1 is what? A perfect square. This is exactly what we want. To have a perfect square or to have what? To have a 0. To have a perfect square or to have what? A 0. So 1 is a perfect square. So therefore, what does it mean? The roots are what? Rational. Remember the condition of being what? Rational. For all rational values of k, our roots are rational. Show that the roots of this equation, the roots, guys, the roots are rational because the discriminant, your delta, is a there is no way, guys, when you have a perfect square, you have got real, rational, and equal. We are not focusing about these other two. We are focused about being rational. It was going to be either these two. So we obtained it on the other one, which is what? For a perfect square. So this is the condition. So we therefore conclude. So therefore the roots are what? Therefore the roots are rational. This is the condition of our question. Our question is answer the question. They are not asking about these roots. Are they going to be real? They in unequal what? No, answer the question. For a perfect square, what is the question here? Are they rational? This is what the question is all about. So to obtain a rational number as a root, for us to have a rational number as a root, the conditions were going to be 2. So you test these 2. So this is how you answer your questions. Do as many questions, guys. Using this idea, you won't go wrong. There are so many conditions. They can ask for any condition, guys. They can ask for anything. Remember here they said what? Rational. In the other question, they are going to ask you, the roots are what? Irrational. So you check, where do we have irrational numbers? When it is what? When we do not have a perfect square. So it means when you simplify your algebraic expression and you do not obtain a perfect square, it means we've got what? Irrational. And also on a perfect square, our answer here, we got a number here. We got a direct, a numerical value. Guys, it is not always the case. We might have an expression in terms of k. We might have an expression. Let's say you are given whatever that you're given as an expression. You factorize that expression, you obtain something like 2k plus 1 squared. It is a perfect square. Or maybe you simplify everything. You just remain with something like 4k squared. It is a perfect, as long it is giving you the perfect square situation here, a number raised to the exponent of 2. As long it is giving you the condition 4 is a perfect square, k squared is also a perfect square. So it is not always that you are going to have a number here like 25, like a 16, like a 100. It can be an expression. Here it is because everything cancelled. So we cannot say it is because of everything cancelled. That's why we are using what? We are using a number that we got. We are comparing using a number. If you still have the k on your answer, this k, compare it to say, can it be written in this manner? Or maybe it is just giving you a direct term, which is maybe like 4x squared, or it is 4k squared, or maybe it's 9k squared, but it is a perfect square. You know that they are rational, or it is equal to 0. Maybe you simplified here and you got a 0. It was going to be what? Rational again. Those are the conditions where you get what? Rational solutions or rational roots. The opposite of that one is true. All right. So guys, let's revise as much as we can. We shall meet again in other classes, preparing for our tests and examinations, which are ahead of time.